A statement made publicly by Bugatti's CEO was intended to draw a clear line in the sand about what could and could not be done outside the company's tightly controlled ecosystem. He looked directly into a camera and said they simply didn't believe it was safe, and that was the reason independent repairs on Bugattis could not be supported. It sounded definitive, almost final, like the kind of claim backed by unshakable authority. But what followed over the next stretch of time quietly dismantled that certainty. Not once, but twice, in two entirely different situations, on two separate cars, in two different countries, by one individual working without factory backing, without official documentation, and without any of the institutional support the statement implied was essential. That individual was Matt Armstrong, and what he demonstrated wasn't just mechanical skill, but something deeper that challenges the entire premise of what qualification actually means in the world of high-performance automotive engineering. Because on paper, qualification is easy to define. Its certificates, manufacturer-approved training programs, access to proprietary systems, and the polished environment of authorized service centers. But when a car stops working in a way no manual anticipates, those credentials don't always translate into answers. Real qualification shows itself in the moment something breaks unexpectedly, when there's no guide to follow and no one to call. It's the ability to reason through failure, to understand systems not just when they operate correctly, but when they don't. That distinction becomes critical when looking at what happened with the Bugatti Chiron. This wasn't a routine service job or a minor repair. It was a crashed hypercar, effectively split into sections, the kind of situation that would normally be handled exclusively within factory walls. Bugatti had made it clear that rebuilding such a car outside their network wasn't just discouraged, but effectively impossible. Yet, in a garage environment, without access to official manuals or torque specifications, Matt began the process of putting it back together piece by piece. One of the most telling moments came when dealing with the titanium bolts that connect major structural components of the car. These aren't just any fasteners, they're critical to the integrity of the vehicle. Bugatti had not released the torque specifications publicly, reinforcing the idea that such knowledge was locked within the company, but the information wasn't as inaccessible as claimed. It had already surfaced, quietly, through independent channels shared by someone who had documented the process elsewhere. Matt found it, verified it, and used it correctly. That single instance exposed a flaw in the assumption that knowledge could be completely contained. It showed that information, once created, has a way of spreading beyond intended boundaries, especially when others in the field are willing to share what they know. But the rebuild didn't stop at simply finding hidden data. In some cases, there was no existing solution to follow, and that's where the work moved into entirely different territory. A structural bracket within the car had failed, an aluminum casting that had fractured under stress. Replacing it with an identical part would have meant reinstalling the same limitations that caused the failure in the first place. Instead, a decision was made to improve it. By analyzing the casting, identifying where material had been absent due to manufacturing constraints, and then fabricating and welding reinforcements into those voids, the repaired component became stronger than the original. It wasn't just fixed, it was redesigned in a way the factory itself couldn't achieve during mass production. That kind of freedom to focus on a single component without the compromises required by large-scale manufacturing allowed for a level of refinement that challenged the idea that factory-built always means best. The contrast between this approach and that of an authorized dealership is where the broader issue becomes clear. Dealership technicians operate within a structured system. They rely on diagnostic tools, step-by-step procedures, and predefined solutions. When a car arrives functioning but in need of maintenance, that system works efficiently. But when something falls outside those parameters, When the problem hasn't been documented or the solution hasn't been written, the process can stall. Requests get escalated, approvals are needed, and progress slows. In the case of the Chiron rebuild, there was no procedure to follow because the situation itself wasn't supposed to exist outside the factory. So instead of following instructions, Matt effectively created them, step by step, solving problems that had no official answers. There was even a moment during the process that hinted at something interesting happening behind the scenes. A message arrived containing detailed gearbox oil specifications and procedures information that would normally be restricted to internal systems. Whoever sent it made a deliberate choice to direct that knowledge to someone actively solving the problem rather than keeping it confined within official channels. It suggested a recognition, even within the broader network, that capability isn't defined solely by affiliation. If the Chiron rebuild demonstrated the ability to handle the extreme, the Bugatti Veyron provided a different kind of test entirely. This time, the car belonged to Matt himself. It came with no service history, no background, and multiple visible issues: a gearbox that wouldn't engage, an engine misfire, and a coolant leak. For most, this would be the starting point of a long and expensive diagnostic process. Instead, it became an exercise in applying first principles. The gearbox issue, for example, wasn't approached as an isolated failure. Instead of assuming internal damage, the focus shifted to the systems supporting it. Observing that the hydraulic pump cycled without building pressure led to a logical conclusion. The gearbox itself might be fine, but it wasn't receiving what it needed to operate. Testing confirmed that theory. The fault traced back not to a major mechanical failure, but to something much simpler: an electrical issue rooted in a damaged fuse setup. The evidence of previous attempts to fix the problem was visible in the melted housing, showing a pattern of escalating fuse replacements that ultimately caused more damage. Correcting it restored function almost immediately. The misfire followed a similarly methodical path. Understanding how the secondary air system interacts with the engine sensors allowed the issue to be traced back to airflow irregularities caused by a non-functioning control component. Again, no manual was required to reach that conclusion, just an understanding of how the system behaves under different conditions. Even something as straightforward as locating a hidden coolant reservoir revealed another layer of insight. Instead of searching blindly, the location was predicted based on how similar systems are designed across different models. That ability to transfer knowledge from one platform to another is what makes independent problem-solving so effective. It's not about memorizing layouts. It's about Hascanal why components are placed where they are. Looking at everything together, a pattern emerges. The official network is designed for consistency, for maintaining vehicles within known parameters. It excels at keeping working cars in optimal condition. But when something breaks in a way that falls outside those parameters, the approach needs to change. It requires adaptability, creativity, and a willingness to operate without a safety net. Over the course of these projects, what's been demonstrated isn't just competence, but a different model of expertise, one that doesn't rely on exclusive access or controlled information. Knowledge has been uncovered, shared, and expanded in public, creating a resource that didn't exist before. Each solution adds to that pool, making it easier for others to follow. The original statement claimed that such work couldn't be done safely or supported outside the factory, but the evidence shows otherwise. Not through theory or speculation, but through documented results. A Chiron rebuilt and running, a Veyron diagnosed and repaired, and multiple problems solved without any official involvement. It raises a simple but important question about where true expertise comes from. Is it defined by access to systems and documentation, or by the ability to solve problems when those things aren't available? Because when a car stops working and no one has an answer,